So this talk doesn't have a definite set of topics. I have a bag of things that I can pull rabbits out of. And what I need to do first is get a sense where everybody's at, okay? Because the most advanced version of this talk is us literally doing nothing but going through library code. And that's essentially the kind of book this talk is presaging. But there's other things I can do. I can get in a little more softer stuff, talk about what it's like to use Haskell, things like that. So let me get a sense of where everybody's at. First, some of you will be familiar with the Haskell Book, which I co-wrote with my author, Julie. And this covers a fair bit of language. Most people call it a beginner book. It's actually like 2/3 beginner, 1/3 intermediate in terms of coverage. Now, first let's start. Raise your hand if you've actually read the book and done the exercises and all that deal. Okay, so like 30–40% of you. Okay, cool. All right, those of you that didn't, would you say, raise your hand if you know most of these topics pretty well? Okay, so we have a couple more on top of the 30–40%, which means about half of you are going to be hellaciously lost if I dive into library code immediately. Okay, so we'll do a bit of that. We'll do a bit of that. But what I'm going to do is, since about half of you are going to be with me and half of you aren't, I'm going to plan on covering fewer libraries, but I'll take more questions. Okay? Now, I'm going to try to answer the questions I can and explain what I can, but I'm not going to answer questions like, what is functor? I'm sorry. It's not going to happen. I'm going to try to cover more like idioms, how we use these libraries, things like that. Deal? All right. So, what this talk is about is essentially the next thing that I'm going to be working on. See where the talk title came from? Right? So the Almanac, the idea is to write in an intermediate resource, a follow-up to the Haskell Book. And what I'm focused on is kind of a cookbook, but not just examples like most programming cookbooks you may have read. Instead, what I'm trying to do is get people to a place where they can comfortably read code they didn't write. And the reason I care about that is if you want to use Haskell, you're not going to have documentation and examples for everything you want to use and do. For some stuff, or popular stuff, yes, you will. And those examples will be really helpful. But sometimes you're just going to have to read the types and read the code. Right? So, how many of you have parsed or generated JSON before? Okay, seems like a couple of you are liars. All right, so the standard package for parsing and generating JSON in Haskell is ASON, named after Jason the Argonaut's father. Yeah, cheeky Irishman. All right, so the design of ASON is actually pretty interesting in its own right, because it represents a pattern that you'll see over and over in Haskell. Maybe not frequently, but it definitely comes up. And the idea is that you have this abstract syntax tree. They aren't actually going to show it here, so I'm going to skip over to my thing. They have this abstract syntax tree that represents JSON data, right? And JSON could be an object, which is basically just a hash map of text to value, which values then just any other JSON value in the universe, right? Or it can be an array, and a JSON array is just an array of more JSON values. Those values can then be anything that's a valid JSON value, whether it be more objects, numbers, strings, or even more arrays. String, number, bool, or null. There's a pretty reasonable example in the ASON documentation. It uses this person data type, and this instance right here, this is for ASON, right? This is your from JSON instance. So this is how you take a chunk of JSON and potentially turn it into a person value, right? So I say potentially because it may not actually be valid JSON that you can pull a person out of, right? For example, our parse JSON method here is pattern matching an object, right? What if it's an array? Then it's going to fail, right? So part of what makes JSON nice is it doesn't go directly from raw bytes representing JSON to your value. It uses that intermediate value type. So when we pattern matched on object in that from JSON instance, we're just pattern matching on this, right? And if you take a look at, I pulled the Antler grammar for JSON out of the standards website. Does that look familiar? Looks a lot like the Haskell, right? Okay, there is one difference. They just encode the bool literals directly, obviously, but same idea. So an object is a hash map of text to value. So text is just a Haskell type that lets you represent human readable text, as distinguished from byte string, which is any bytes in universe. It's like a byte array in Java, right? Same idea. And then value here means that our value type is recursive, right? Because a value type can be an object, which is a hash map of text to value, which can then be another object. And that's often what you'll see with an abstract syntax tree. This recursive nesting of data. So, an array is a vector of value. So again, recursive, right? So you can have vectors within vectors, objects, strings, numbers, nulls, bools, whatever. And we demonstrate an example of this right here. Ignore that. And you can see we can have a string value blah. We can have yet another array with an object within it, with a textual key of 1 to the numeric value of 2. The string part isn't too interesting, although I do want to point out one thing. You see how it says data.text.internal.text? This is just because I'm dumping it from my REPL, so it includes the full path to the type, right? Okay, who can tell me which text that is? Who knows? Because there's two different text types, right?
Lazy strict.
Okay, we've got one person saying strict. Does anybody disagree?
Yeah.
Okay, what is it? Well, it's got to be strict or lazy, right?
Right. Oh, okay, no. Actually, I think when it's lazy, it actually has lazy in it, so it has to be strict in there.
That's right. That's the exact rule that I give here. So, wow. So, there's actually comments there.
Is the lazy in the correct position? Because for text and byte string, the lazy is on different sides of internal.
They're different libraries. You can put it wherever you want. They're also written by different people. So that is in the correct position. That's how it's defined in the text library. You are correct. Lazy goes a little bit later-ish in the byte string modules, but it doesn't matter. It's just the name of the module. So, I'm sorry, I have comments here, but the projector's color gamut doesn't capture that.
Can you select the text?
Yeah, I think that's going to be the answer here. There we go. So, if you ever wanted to feel like a kid again with the lemon invisible ink, I found a really expensive way to recreate that experience. Yeah, so basically the rule of thumb with text is if it doesn't say lazy in the module anywhere, it's strict. If it says lazy, then you know it's lazy.
So it's just a convention, right?
I mean, it's not even really a convention. I'm just developing a mnemonic for remembering why Brian didn't put strict in the strict module. So, I mean, I guess it's probably because the strict is kind of the one you should default to unless you intentionally want to stream a text value, but it doesn't really matter. And then we have the same thing here for byte string. The same mnemonic happens to work for byte string, but don't count on it everywhere. Although it does work for containers, now that I think about it, so fair enough. Alright. And then I'm not going to talk about number, bool, null, it's boring. Actually, here, real quick. Who here is familiar with the scientific library, or type, for that matter. Okay, so quick note on scientific. Use it to represent data. Don't use it for like arithmetic operations on data necessarily, because its num instance has partial functions in it. So what scientific is, all right, so by default, when you want like fractional-ish numbers, use double, right? That's like the default from Prelude. If you have a fractional A, I'm pretty certain that's the type default as well. So scientific is a way to have an arbitrarily precise representation of fractional numbers. Now, admittedly, rational also does that, but it also blows up quickly compared to scientific in terms of size. Because rational is just like, it's just denominator and numerator of two integers, so it's not perfect. Okay, so we jump back up here. So just to comment on this a little bit more, so this little helper function here, that is essentially, when you pattern-match an object, V is now the underlying hash map, right? So you now have a hash map of text to value. This little helper function here gives you a convenient way of accessing keys in that hash map. Now, you can use the hash map lookup function, but here's why you don't. The hash map lookup function returns maybe value, right? But what you're in parse JSON is not maybe. So you're in the ASON parser monad, right? So if you did use lookup, you would have to keep lifting it up to a parser failure over and over if the lookup didn't succeed. So the helper function spares you that grief. It takes the object, and keep in mind this is just a type synonym, right, for hash map text value. And then you give it the key, which is a text value, and then it gives you, A of from JSON A. So that's the other thing it does. It doesn't just lift the maybe into the parser failure. It also handles automatically delegating to the next from JSON instance, because often when you're parsing objects, there's yet another object that has some specific type with yet another from JSON instance, that sort of thing, right? And then go back to that. Do I hear a question? No? All right. Then, what you're doing with the person data constructor here is you're lifting over the first value, so that's name, text. So you're getting the name field out of the object. Doesn't have to be the same. Obviously, it's whatever key the value inhabits, right? And then you're lifting it over that. And then when you go to get the second parameter, your function, your partially applied function, is now embedded in ASON's parser type, right? So what happened was you had text to int to person. Then you ended up with parser int to person after that first lift over the name. So if you look at fmap, or the infix version you saw there, you don't have any structure around the f here. So it works for the first, but not for the second. So what you need is applicative for that extra f, right? So if we bounce back here, the extra f that our partially applied function is embedded in is the parser. Then we have toJSON. You can probably guess what that does. It allows you to generate JSON for a Haskell value. And conveniently, the AST is useful here again. You don't generate raw text yourself, right? You just generate a value, of type value, some unfortunate naming. And you also get helper functions for that as well. So object is a pretty common, also ignore the two encoding, that's like an optimization thing for skipping the in-reader representation. So object takes a list of pairs and turns them into a value. Well, okay, what's a pair? Well, the idea here is that you just have this list of key value pairs. The little assignment thingy there, that's from this type class. And it's called key value. And one of the instances for key value is pair. Right? So you're just constructing key value pairs. That's it. This pair itself is just a type synonym for a tuple. So you have the name of the key and then the value. And then all it's really doing for you is calling to JSON on your value. So, because in an object, in your JSON type, it's hash map text value, right? So your name in your person type is text. It's not yet a value. So what's convenient about this is just going ahead and calling to JSON on the right-hand side, so that it lifts that text into, in this case, it's just going to pack it in the string data constructor. And that's essentially all it's doing in that case. But it can delegate, arbitrarily deep. And just keep going. And we're not going to talk about to encoding. We talked about that a little bit. This is the actual implementation of the helper function we were talking about earlier. And you can see how it's actually doing the hash map lookup right there, right, of key and object. And the result is nothing or just A, of course. And when you get nothing, it uses the fail method. Now right now, fail is in monad. It shouldn't be. It's not actually a proper part of monad. They're going to split it out in the monad fail eventually. Hopefully it doesn't take as long as functor applicative monad did. And they're just saying key, whatever the key was, not present. Right? Then under your just, they do a couple things here. So ASON added some tricks to make it a little easier to debug a JSON parse fail. And one of those things it does is the modify failure thing here is basically just adding the key to the potential error. And if you choose to, you can actually get it to report a path. But you have to turn it on. And then here we're just doing parse JSON feed, and then it's annotating it with key. We'll skip the parser type for now. Okay. So bouncing over to some more code that uses ASON. So how many of you are familiar with Elasticsearch? Okay. How many of you actually like it? Yeah. Yeah. So, I wrote a library a year and a half, 2 years ago. No, two and a half. And it's called Bloodhound. And it's essentially a client library for Elasticsearch, right? Now, the reason I wrote it was because writing those JSON queries that Elasticsearch wants is a massive pain. Hated it. Hated it, hated it, hated it. I would always get something wrong, right? So I thought, hey, maybe a Haskell library could make this easier, right? So what it essentially does is it takes the entire Elasticsearch API, the query language, and turns it into one big series of data types, right? And then you just construct your query from normal Haskell values, nothing too fancy. And then it has some client, machinery, utility, so that you can use an HTTP client, you can point at Elasticsearch server, turn it into JSON, run the query, right? So these are just some examples of some of the odds and ends it can do, like deleting an index, creating an index. That's too interesting. I think what we're a little more interested in is stuff like query. So we can see here our query to start with is a term query. In the term, we're giving a user invited now. Okay, so let's take a look at term. And that's the term type right there. It just takes a field and a value, and that's it. So bouncing back here, then we've also got a filter. So this filter isn't actually going to do anything, because what we're doing is we're actually taking the identity filter and ANDing it with the identity filter, which is just another identity filter, which then doesn't actually filter anything out, right? And then to construct the final search query, we use a little helper function called make search. That's essentially just to set some defaults in the values, because most of the time you really just want to set query or filter or both. And then you can run it against an index. Get a reply, and see your response. So taking a quick look at search. Yeah, so you can see why we have that little helper, right? Because most of the time we care about the query and the filter. I don't know how much everybody here knows about Elasticsearch, but queries and filters are really different things. A filter is more like something you would do with a database, like Postgres, where you're using an index against fields and there's no actual like full text analysis or anything like that involved. And then query is more about like search, right? The rest of it are just odds and ends that you might need, like sorting, aggregations, highlights, track sort scores, from size of your paginators, right? It's a little bit unfortunate that they do pagination like this, because you can't actually have like a stable paginator that way. I don't know if anybody's ever run into this. Yeah?
Can I misuse a query for something that I would actually use filter for, or is it like totally different?
Sorry?
So I can do queries, or I can do...
You can do both at the same time if you want.
Oh, okay.
So actually filters are pretty useful if you know there's some criteria that should absolutely disbar a document from consideration. You can use that to essentially decrease the size of the set that the query has to work over.
Okay.
Right? But a filter in general is just anything that would be like a where clause in a normal database query.
Yeah.
That expression is a little bit misleading, because you know how you can use like queries? Yeah, that's query, not filter. When you're actually doing, using the search index of the corpus and yeah. All right. And then search type, field, source, yada yada. It's just a bunch of odd and junk very few people use. All right. So that's why we have the make search helper. And these are the different search types it can be. And Elasticsearch surely has quite a lot of stuff it can do. All right. Let's take a look at filter. See what the deal with this identity filter thing is. So this is the filter type. So you can have an and filter, or filter, not, identity, bool, exist, geo, IDs. IDs are literally like the document ID, so you're passing a list, and you get that list of documents back, that kind of thing. You can use that for like scoping the query to just that list of documents. That's one example thing you would do with that. Limit, missing, prefix, query, range, regular expressions, and then a regular term filter. This is just like, we can't avoid this, right? Like this is just Elasticsearch's API. These are all the things you can do with a filter, right? But the good news is, now it's explicit, right? So if we take a look at, So this is the 2JSON instance for filter, and this is essentially how we generate the JSON query for Elasticsearch, right? So we're essentially just pattern matching on each constructor and just writing it all out, right? And then you can see the identity filter right here. There's your match all, right? So if you and a match all with another match all, you just get another match all, right? All right.
I mean, when you send a query, you just have it completely filled out. Don't rely on any Elasticsearch details.
I'm sorry?
When you actually have the query all built, you're going to send on the wire to Elasticsearch?
Yeah, so the question was, do we build the query, you know, the whole body up front? Yeah, we just build the whole JSON body and we send it over through an HTTP client. That's
what I meant though is you like have match all. And you could leave that off, but it's going to be there and be like a no-op kind of thing when you send it.
Yeah, so we used identity filter in the example just because it wouldn't actually do anything.
Right.
And you can leave it off. Obviously, you don't have to have a filter because in the search type it said maybe filter. So you can just have just a query and then nothing for filter, and then you don't have any filters at all.
Right.
It doesn't. So that doesn't have to be in there at all.
So is there any other use of having identity filter as one of the data values?
Is there any use for having identity filter? There is if you want a base case for recursive construction of the filter. That's just handy for that. I mean, I guess that's like a lazy thing to do. You could filter it back out after the fact. But if you want to know why it's there, you're going to have to ask the Elasticsearch people. I'm just constructing ex post facto justifications, right? I didn't make it. Let me see here. So another thing to note is that, as we recall from this little helper here, remember the pair constructor? It's calling 2JSON on each of these as well, right? So all of these types have 2JSON instances. And to make that point, yeah. So that's why it's able to delegate to those other 2JSON instances of those other types. So we can take, for example, field name here. So that's just going to be field. Oh, field type. Okay. All right. Yeah, fair enough. Let me grab query. So we have term instance 2JSON term order, term inclusion. Yeah, so every constituent component of this big tree of types, they all have their own 2JSON instances. And it makes it a lot simpler to write these instances. Interval for time intervals. We have those, and then query. This is query. Nomenclature in query is a little bit unfortunate, because if you follow the prefixing strictly, you end up with, there we go, query simple query string query, which contains a simple query string query, right? So, I guess hobgoblins of little minds won the day. And then if we go to simple query string query, we get that guy, right? And then this, all of these have their own 2JSON instances, right? And simple query string query is exactly what it sounds like. You're just writing like a simple query string. You can use a little bit of Elasticsearch's, special syntax in it. But other than that, you're not doing a whole lot with it. And then if we back out a bit into the client, so this is the this is essentially where the sausage gets made. And this is what actually takes the URL, takes the JSON body that you intend to send to the Elasticsearch server, and then actually dispatches it. And you notice we parameterized out method, and that's because Elasticsearch has a little bit of restfulness in their API. So in some cases you want to get, post, put, so on and so forth. So I'm going to pause here just real quick before I get into more of the client and take questions. Yeah.
So I noticed that in the data declarations or how definitions, the values were not strict. Is that something?
Just didn't think about it.
Okay.
Yeah, it hasn't bitten us. We could go through and do it. It just doesn't matter. Toby?
Yeah, I don't know if it really matters or if it's like the. Okay, whatever. You be the judge. So I saw that you're deriving typable for most of those data types.
Yeah.
What do you like? I don't know exactly what it's for, or why do we need that?
Let me think here. So usually when I derive typable, it's because I need to make an exception out of something. I don't actually remember why we're deriving typable here, because I wasn't. Basically, one of the other maintainers asked if they had permission to slap typable on everything, and I said yes, and I didn't really investigate much further. But let's see if we can take a quick look and find out what's going on.
And the same thing, I also saw generic there.
Yeah. Well, the generic is because so most of the to.json from JSON instances, most of those are handwritten. But the dumb new type wrappers, we just generically derive those because they're just little pass-through types, and we don't want to have to write those manually. If we were going to be proper about it, then yeah, we would dump the generics and do them all manually. But we have like 100 new types in there because we really don't like passing around raw text or int or anything like that. We're very persnickety about that, so we generally just use generics to throw a little sugar on top. I don't know. I'd have to ask that other maintainer.
I can also just like rephrase the question somewhat and ask like if I see that you are deriving typable, like what can I assume, like why do you usually do that?
Well, so typable is a fairly I'm gonna call it generic type class. It just provides one very simple facility that essentially creates like a. It's best if I just show you typable. The most common use is because you need to define exception for a type. If you want to throw like a type as an exception. As far as the actual typable, yeah, so what you're doing is you're just getting the ability to get a type rep for a type. And it's basically just like a runtime witness to like a type constructor.
Okay, all right.
Yeah, it's not terribly interesting.
Yeah, okay.
Question?
Yeah.
How do you maintain this in face of changes to the Elasticsearch API? Do you have any technique or just...
How do you know that sucked? So the question was, how do we maintain this library in the face of Elasticsearch's continually under-documented API changes that haunt our dreams? Yeah, so that's been a problem. And the policy until recently has been, we do not break 1.x. People can use whatever works on 2.x or 5.x because the breakages were common enough, but they weren't severe. They're usually in weird little like dark corners, right? I think one of the 1.x to 2.x breakages was something to do with date filtering, something like that. So the policy we're moving to now is we're splitting the entire API into version-specific modules. So there'll be database.bloodhound.v1, .v2, .v5. For now, there's just v1 and v5, because the guy who will probably write v2 doesn't have time just yet, but he'll get to it. And then when we do that, we will commit to keeping v5 working on v5, v1 working on v1, and then leave it at that. You're probably wondering, what about duplication? We're just copying and pasting for now. We'll refactor later. The reason we're copying and pasting for now is because if a data type representation needs to change because of an API change, we suddenly have to re-split them anyway. Right? So it's like, what do we really win out of sharing a type between them? Realistically, you should consider different versions of Elasticsearch entirely different databases anyway, because you can't trust their APIs to be compatible or anything. It's not like upgrading from Postgres 9.4 to 9.5. It's not like that. They change the language each time. All right. Any other questions before I move on? No? All right. So yeah, that's the core dispatch function. And if we bump down a bit more, you can see the little helper functions for doing delete, get, head, put, post, right? This is also where the random utility functions are for creating, deleting an index, snapshots, things like that. One thing you'll notice is, so for like get nodes info, for example, you see how we've got this monad BH constraint, and then it's M. So we used to just have concrete I/O and argument passing, because in order to run an Elasticsearch query in our library, we really only need two things. The ability to perform I/O, obviously, and also just the config value for telling us how to talk to the Elasticsearch server, what its address is, that sort of thing, right? So if you take a look, so we have an instance of monadbh right here, and you notice it's not really doing much because it's for the BH new type, and it's just reader T, and we derived a lot of stuff for that. And then the BHM itself, no, that's semi-nearing. Yeah, so here's the BHenv. So this is the thing that tells it how to actually talk to the Elasticsearch server. So we have just the server, which is, you know, host, name, stuff like that, port. The manager is a connection manager for the HP client. So you don't have to spin up a whole new connection each time. And then we have a request hook here. We added that semi-recently. Somebody needed to be able to hook into the results. Then, let me jump over to monadbh now. So, monadbh here is just a reader for BHenv, right? It's just tell me how to get the thing that lets me perform queries. The only other thing is it requires functor, applicative, and monad.io. And monad.io is just so that you can lift I/O over anything. So the point of this class is so that you don't have to manually lift the entire Bloodhound API in order to use the Elasticsearch functions in, say, a web app monad, right? All you have to do is define a monadbh instance for your web app monad that just tells it how to thread around the data that it needs, right? And then you're done. Now you can use them transparently in your SOD, Scotty, whatever application, transparently, as if they actually inhabited that instance. This is usually called MTL style. It's not the MTL library. This isn't from the MTL library, right? But this is the approach, if you will. This is a very simple example of it, though.
Do you have an example showing that? Or? Like how you make an instance of this?
Well, so there's one right here, right, for reader T. Because in order to get a BHM value out of a reader T, you're just going to use ask from the reader, the helper function from the reader module, right? And for this type here, your monad BH is just packing the get BHM. It's essentially delegating get BHM to the reader T instance. And you already know what that's going to do. That's going to ask, right? So it's that kind of recursive delegation of type class instances. It's a lot like what you're seeing with the 2JSON instances. It just kept delegating to the next 2JSON instance. That's how a lot of lifting and things like that work in monad transformers as well.
So what's the runtime implication of this performance? I mean, is it?
No, I can't do that justice right now.
Okay.
Yeah, in general, things will get inline to perform fine. Transformers are one of the faster ways. MTL is probably the fastest way you can structure your effects in Haskell right now. Slower would be something that requires reflecting at runtime on a dictionary like F, but you shouldn't be using F anyway, so don't worry about it. Okay. So, any other questions? Yeah.
How did you, the geographical, so Elasticsearch lets you do geographical queries.
Yeah.
How did you handle your geographical type and queries?
Okay. You want to just take a look at the data types?
Yeah.
So the question was about how we handle geo queries in Elasticsearch. So let's start with geo bounding box constraint. So that's, I think that was a type of filter we were looking at, was it? Yeah. So, yeah, because it's not touching textual data, of course. Okay, so your geo bounding box constraint, it has a field name, so it knows what your actual geo field is. And then there's the actual constraint box. Then you have a cache param, and then there's the actual geo filter type. Taking a look at your geo bounding box is top left, bottom right, latitude, longitude. And defining those two corners gives you your bounding box. And then your geo filter type is memory and indexed. Do you want to see another one, or is that good?
I got the full picture.
Sebastian?
Going back to the maintainability thing, have you guys thought about trying to generate these data types from documentation or something like that?
Oh, Elasticsearch is not documented.
Not really enough, right?
No. They don't even, when you go to their documentation, their examples don't even include a complete example you can copy and paste. They include like arbitrary fragments of the AST.
Yeah, sometimes that doesn't even work.
Yeah, I mean, I've complained at the Elastic people for a couple of years now, begging them to define or put out some kind of spec that we could then machine translate into types.
I see.
They won't. Are you thinking of Amazonka when you ask that?
No.
Because that's what he does.
Yeah.
Yeah, he just takes the entire like AWS API spec and he generates the entire, code gens the entire library from that. I mean, there's a little bit there, and he, obviously like how the code gets generated is part of an API design that he put together, but the actual work is just like, he just takes their machine spec and spits out an entire suite of libraries. We can't do that. That's part of what makes it such a pain. Yeah. No, I wish we could do that, but I gotta get them to write a spec first. Yep. Any other questions?
Could you go through the update document function?
Yeah, sure. So, going through update document here, we've got a few different parameters. We've got index name, mapping name, index document settings, patch, doc ID, and reply. So, index name is pretty obvious. You have to tell Elasticsearch what index you're actually poking at. Mapping name is basically specifying, I guess what you would call a schema. I strongly recommend defining a schema for your data in Elasticsearch and sticking to it. If you do not define your schema, Elasticsearch will find an excuse to mangle or destroy your data. I promise it will. I
fell into the trap.
Yeah, so he's fallen into that trap as well, and so have I. And it's really unhappy making. So then index document settings. Let's take a quick look at that if we can. I'm actually gonna get that going.
I was about to suggest that.
Yeah, I didn't have my tags built, so I can't do my little go-to definition thing, but as soon as they're built, they'll be fine. Thank you. So meanwhile, all right, it's gonna be in client. Or it's not. Ooh. Types. It is in types. I must have mistyped the type. Mistyped the type. Index. Document. Settings. There it is. Okay. And then this is just version control and document parent. The version control thing is basically you don't have real transactions in Elasticsearch. The version control gives you a little bit of control over what's actually happening. So you can say like update if it's at least this new or this old or that kind of thing. And they have like a little version thing that they bump. It's a little silly. Then patch is the actual, it's 2 JSON, so it's just something we can turn into JSON, right? The patch is just the parts of the document you're overwriting. So you don't have to redefine the whole document, just the parts you want to overwrite. Then doc ID is exactly what it sounds like. It's just Elasticsearch's version of a primary key. It's just not quite the same thing. And then we have monad BHM reply. You get this on almost every function in the client module. The actual reply itself is basically just the JSON response that has some standard fields and things that you get back. And you already know what monad BH is.
But monad BH was for the, wasn't it for the, sorry? Environment.
So let's take a look at reply. So you actually saw what a reply could look like in that example from the documentation. So here we're decoding a search result, either string search result, out of the response body. The reply itself isn't interesting. It's just the standard HTTP client response. And the L byte string there is just saying that the type of the response body is a lazy byte string. So that's just where the JSON of what Elasticsearch is telling us lives. Then, from there, you tell it what actual type of response you expect, because Elasticsearch doesn't reply consistently to different API calls. Some of them will be search results, some of them will be other things, right? And then here we're just decoding it manually. You don't have to do that. And then we're just getting the data out. And a hit is the search hit, the matching result. Then going back. Okay, and then we're just pattern matching on that data. The bind M2 is just a helper function. Let me talk about the URL a little bit. So we've written a lot of these little client helper functions. So we keep having things like, so join path just takes this list of path components and joins them into a valid URL path. That's all. Nothing interesting there. And then add query is just adding a query parameter to the same URL. And then body is pretty obvious. I think it's just and then encode returns a byte string. And then we're just encoding an object which has a doc field, and doc equals the patch, the object that actually has the fields. Then bind them to is just this helper function. Yeah.
Oh, I was wondering.
What about the type signature for me, please?
I'm sorry?
Could you explain the type signature?
Yeah, sure. All right, so we've got a function a to b to mc, ma to mb to mc. So it's called bind m2 because it's kind of like lift a2, but we actually have to do a bind. And essentially what's happening here,
You don't need that applicative in anymore.
we did when we supported compilers that didn't have functor applicative monad. Let me make this a little bit bigger. Okay. How many of you used lift A2 before? Yeah, okay. So, who can tell, well, you see it stripped the constraint. Yeah, it just strengthened all the way to monad and left it off. So, who can tell me what part of this type signature explains why we can't write this in implicative?
A2 and A1.
Hmm?
I mean,
The fact that the function returns something inside M.
No, it's reordering the args. No?
Like, it feels like whatever you do, you're gonna end up with an M of N.
Well, let's take a look at join and lift A2. Whoops, I gotta actually import it. All right. Okay, so what's different about lift A2 from bind M2?
MC.
Oh, it's MA.
Yeah, because it's actually a monadic function that generates more structure that we have to then reduce back down, right? So this wasn't us trying to impress anybody. It just kept happening in all of our helper functions, so we extracted it out. That's all. No great crusade to look smart in front of anybody. It's just, it happened. So we made a function.
We in control monad.
And if we take a look at bind M2 here, we can see where our post function. And you can see how the type of post is text made by string M reply, right? That's your M and your A2, A1, MA.
So the M is
A2, A1, MA. Yes?
Isn't M the request context? I mean, so to speak.
Well, it's going to be monad BH in this case.
Yeah, monad BH, which is my understanding was that it was for like host name, port number, that kind of stuff.
Yeah, so it's still a monad.
Why do we want to get it back in that context? And that's
The way to think about readers is not give this to me now. Write a program in terms of the thing you will eventually give me. That's the way to think about reader.
Okay.
Right? Because the reader doesn't go away until you supply the value that runs the reader.
In this case, the value is the environment stuff that you have to give it in order for it to connect
the
to
BHM. Yes. Yeah, and the eventual argument you're supplying that lets it run the code is the BHM value that contains the information it needs to actually run the request. Until then, we can program in terms of a monad that's this deferred, pushed out function argument, essentially. And then that ends up being it. That's it. That's the whole update document function. Do you have any more questions about that, or are you good?
I'm good.
Okay, cool.
So why couldn't that have been a reader alone? And
Sorry?
you could have just defined a reader, right? And why should it have to be a
Why couldn't it have just been a reader? It was, but we didn't want to keep manually lifting a reader through different monads. So we extracted out the reader. into an MTL style class. Prior to that, there was no reader. It was just a function argument in I/O. Previously, we just had, the config parameters as the first argument of every API function, and then in the final return position was I/O. We're just adding we're doing the work up front so the consumers of our API don't have to do it every time they use the library. That's essentially all it is. We're doing a little bit of pre-lifting. We're making it so that they can make like an automatic instance that supplies the data it needs, and then they don't have to do it ever again. It's better, think of it this way. It's better that you lift once in one place in an instance or in a module than that you lift over and over and over in your application. Right? So be wary if you're lifting something in your application code in a way that it'll just keep proliferating, right?
Just like RunDB.
Yeah, exactly. Just like the RunDB thing we talked about. All right. Before I move on to the next bit, any questions? No? All right. So what I'm going to do is I'm going to open this up a little bit, get away from staring at code, take a break. We're at 3:02, so we're going to take an actual break, and then when everyone gets back, I'm going to do a bit of Q&A, and as soon as we run out of the queues to give A's to, we'll dive into another library.
Cool.
All right? So I'm going to switch tracks a little bit now, and I've been doing this a little bit already during the unconference time, yesterday, today, and give people a chance to ask me some questions. A little bit more about my background, if you aren't familiar with it. I've been working as a programmer for almost 10 years now, I think. Started out in .NET, then Python, then Clojure, and now Haskell for the last 2.5 years. Coming up, yeah, 2.5. You probably, by this point, figured out that I worked on a book. I'm starting on the Haskell Almanac, which I mentioned earlier, and something called WarPub, which is essentially my attempt to make a publisher that only publishes good books. Fingers crossed, right? And some people find Haskell very intriguing, but the idea of getting a Haskell job is absolutely an impossibility to them, or just don't know what it's like and would like to know what it's like, just on a day-to-day basis. I'm open to other questions too, just trying to feed you some ideas. So, do we have any questions? Yep.
Why shouldn't we use F?
So the question is, why shouldn't we use F, and that's standing for the effects library. There's not really a good reason to. Anything you want to do, you can do in transformers.
Well, why should I not use it? This was the question. Because you said that earlier.
Right, that's what I'm answering, I thought.
Cool.
Yeah, so there's no reason to use it. Anything you could do with F, for the most part, you could do with transformers. Most of the objections to transformers are, I'm not comfortable with them. I get where they're coming from. It's a little bit hairy at first, but if you use F, you're going to be out on a limb, right? Because none of the libraries you use are designed for it. You're going to have to wrap them all. The way it actually works is essentially you have a runtime dictionary of effects that you're pulling out little helpers, and that can make your code slower, but that's not really a compelling reason for me not to use it. It's just that it's just fancier, but doesn't really pay for itself. That's all. Does it point towards a better direction for structuring effects in the future? Possibly. I mean, certainly it works better in PureScript than it does in Haskell, but you just don't need it. Another question?
You talked about Haskell jobs. People think you feeling like you could get a job in Haskell. What do you say to you looking around and not seeing any jobs? Not like I don't feel qualified, like there are no jobs to apply for.
Oh.
It's side of the situation.
Right. So the question is about Haskell jobs, not seeing any jobs to apply for, not merely feeling, like you aren't qualified, but just no jobs at all. So most of the Haskell jobs I've seen have been London, New York, SF for the co-located ones. There's a small diaspora of Haskell jobs around Austin. There's one company here in Boulder that uses Haskell. But a lot of the Haskell jobs I've run into have actually been remote. Now, the tricky part here is there's more Haskell jobs out there than you might think, but they usually get snatched up by people who know people, usually through open source work. I knew both of my coworkers before I started working with them at my current company. I also work fully remotely. The founder is in Sydney, Australia. The other back-end Haskell programmer is in Michigan. The front-end Haskell programmer, because our front-end app is actually in GCGS, so the whole thing's in Haskell. He's out in Japan, and I'm in Texas. So we're quite remote, right? Fully remote company. It's not like remote with like a home office. There is no home office unless you count the founders like, you know, barbecue and pool. So in general, I think if your goal is to be able to use Haskell in your work, it's probably better to focus on introducing it at your current company. Maybe on a greenfield project. I'm not actually keen on microservices because it makes my types more annoying to make useful, and it just increases ops overhead. But one of the good things about microservices is it makes it a lot easier to sneak in your favorite thing, right? Which I think is actually the secret reason everybody's into it. But nobody wants to admit it at conferences. So if anybody wants to invite me to give a talk about how microservices are actually a conspiracy to introduce Haskell, I'm down. So, but yeah, if you can like a dashboard app or anything that doesn't, interfere with the rest of the company, get a chance to trial it, that sort of thing, that'll help a lot. Not everybody's at a company where that's, welcome. Fair enough. In that situation, a lot of people don't like this answer, but I would recommend building up a portfolio in open source and get noticed. If nothing else, even if you don't necessarily get hired into a company that's already using Haskell, that portfolio is something you can take to your employer as proof that you know what you're doing, that you're engaged with the community, that you know what you're talking about. It's leverage, right? So I don't think I really ever see like a total absence of Haskell jobs, but that's because I'm actually mostly looking at the remote stuff anyway. I think about half of my Haskell gigs have been consulting, the other half have been full-time. I think that's a pretty fair split. Technically I'm 1099 right now, but it's a full-time job. Does that answer your question?
Yeah.
Cool. Any other? Yeah, Kareem?
So if you're going to hire a Haskell developer, what are you going to look for?
So there's actually kind of an anecdote behind that. So the question is, if you're going to hire a Haskell developer, what are you looking for? I can answer that because I've interviewed Haskell programmers. So I used to work for an ad tech company that was using Haskell for everything. Almost everything anyway. And I wanted to develop a more fair interview process because I actually interview very badly when I'm put on the spot. Like whiteboarding type stuff. I can implement a binary tree in Haskell, but I can't like just I can't pull things out of a hat. Like when I'm working, I'm looking things up, I'm poking around, that kind of thing, right? And I think that's most programmers. Is that fair to say? Yes. Right. So I'm not crazy. All right, good. Well, I am, but not because of that. All right. So the more fair interview process. What I wanted to do was to make a homework that they could take home, do on their own time. There was a time limit, but we didn't just deploy it on them. We let them say, let us know when you have time to do it. Whether it's next weekend, next week, whatever. When you have time to do the homework, let us know. We'll send you the problem and start the clock. The problem was a very, very, very simple program using pipes. That's Gabriel's library. You can go bug him about it if you want. And all you had to do was write a streaming average and sum of an event stream, which was just like a very simple like little sum type of a couple different events. Right? That's it. Streaming average and sum. That filtered 95% of the applicants to our open Haskell job. And I don't mean like the code wasn't good enough. I mean it filtered them out as in they couldn't complete the exercise. And one of the people who failed in that way had been in the Haskell community for well over 5 years. So it's not enough to just hang out in the IRC channel. You have to actually write Haskell. That doesn't have to be open source, but we can't afford, I mostly work for startups personally, so we can't afford to pay somebody to do 9 months of churn and burn on our code base. right? We don't expect you to know everything. I don't think I need to prove to you that I care a lot about training and education, right? But if it's not a junior position, there's less overhead tolerated in terms of churn and burn. And this pipes exercise was not hard. We did 1 hour if you know pipes, 4 if you don't. That was our time estimate for it. So that's one example. If I was to use the book as an idea of a baseline, you would definitely want to be comfortable through Monad. Definitely, definitely, definitely. Because it's just going to keep coming up. You can't avoid it. A lot of this stuff gets more optional-ish. I mean, it's not like we actually use StateMonad that much in our applications. It pops up here and there in libraries and little things, but it's not super common. But the big one's going to be those 2 chapters right there. That's usually the sticking point for a lot of people. That's the one where they'll churn and burn a lot, other than streaming libraries. Those are hard, admittedly. So, do you need to be an expert in monad transformers? Not if I'm hired, no. One of my coworkers wasn't super comfortable with monad transformers until he started working with us. And he'd been using Haskell for 10 years. But he got better, right? If he got stuck, we would pair program, figure it out together, and we would both learn something, right? But he had still been writing Haskell, right? He'd been using it for 10, writing it in production for 5, right? So it meant that it was more of a finishing touches thing than having to actually teach him the whole language and ecosystem and things like that. Now, if you're a junior, it's different. There's a little bit more wiggle room. Maybe you landed somewhere in the left column, right? Something like that would be okay. And then there would be a lot more pair programming early on to familiarize you with the code base, things like that. But these are just my personal baselines. These are not the standards of other Haskell companies. Haskell does attract a certain type that likes to ask a certain type of interview question. You might consider that a prompt for whether or not I want to continue to work at that company anyway, right? Because if you don't like those kind of interview questions, then the culture might not be a fit for you anyway. So what I just described is me, and if I'm hired, and what I think our usual requirements are for a position. And for a senior position, I'm basically looking at their GitHub, generally. Like, usually they've made something by then. Because it's not just about working off hours. If you use Haskell at work, you're going to patch libraries. You are going to. It's unavoidable. There's always like some little thing that needs fixed, right? So if you claim you're a senior Haskell programmer and that you've been using it at work, I should be able to find that, right? There should be evidence of that somewhere. Now, I realize some people work at companies that have like restrictive covenants on contributing to open source and things like that. All right, fair enough. If that's the case, I'll just have to talk to them about the different things I've worked on and done, but that's generally where my mind goes first, is where are the PRs they've done, right? But it's not conclusive in and of itself. Did I answer your question? Mm-hmm. All right, cool. Do we have another question?
No.
Yeah, right, you were next, sorry.
How frequently do you find you need a library that is not at the industrial level that you need? Henry today showed a very simple exercise where he couldn't find things that he needed, right?
I'll just show you our work project. Trust me, my boss doesn't care. Okay, so this is our stack YAML for our work project, right? And what we have here are, oh, by the way, this is a monorepo. We use a monorepo. This is one of the best technology decisions I've ever made. I am so happy we have a monorepo now. Because now when we patch things across different sub-projects, it's all part of one big atomic PR. It's awesome. If you haven't tried it, you should. You'll probably have coworkers push back on it. Ignore them. All right. So Hestia is our back-end Yesod app that serves up the API on the website. Thoth is essentially a data access layer and helper library. Friendly ID is just something a coworker made up. It's kind of what it sounds like. It's just like a human-friendly like ID value. And then Rosetta, who can guess what Rosetta is?
Byte strings to text to something else.
GCJS.
Yeah, GCJS, GHC shared domain types. They share the same JSON serialization and types. Not for everything, but for a lot. Okay, so the actual vendoring, you know, how often we actually have to patch something. Figure this is about 10 libraries, thereabouts. Sound about right? Mm-hmm. We have about 225 dependencies. So there's your base rate, 10 out of 225. Now, is that more frequent than your typical Rails app? Well, sure, you can gem install like the whole universe and you still want to touch anything with a Rails app, right? Gem install hairball.
But those are the ones you couldn't upstream patch, right?
Could.
I'm sure you got to.
Well, the thing is that we try to upstream things when we can, but I mean, I'll give you an example. So for GCJS, we've patched the linker twice. The first linker patch has been merged. The other patch is just sitting in PR and has been for 6 months. That's fine, we still have to keep working. We're not going to stop working. So we just, the response, the automatic response, every time we need to patch libraries, vendor now, fix now, upstream, and then get rid of the vendor when it reaches upstream, right? So we have 10 right now, but we may have cycled through like 20 that got removed when the patch got upstreamed, right? I mean, for example, like I'm using a specific version of Johnson's Stripe library, but that's actually quite maintained. I just haven't checked to see if he released the new version yet. So some of that's just laziness. Like we just haven't gone back and checked if we can upgrade now or not, right? So I think that addresses the question of how often we have to patch things.
Yep.
Yeah. Yeah.
How much of an issue has like different styles been to you in your project where you've worked with other Haskell guys together? I mean, like by style I mean like several layers. Like I mean the indentation is one thing, and like then coding style in general. Like.
Coding style and how much of a problem that's been in the Haskell projects I've worked on.
Yeah.
Coding style, not really, especially if you're thinking in terms of syntax. Mm-hmm. It hasn't been much of a problem. So I'll give you an example. Hestia is a Yesod app right now. It started out as a Servant app. Now I'd already had experience with Servant, we'll put it that way, where I ended up replacing it with Yesod because it was too limited for what I wanted to do. I decided to run with it for a couple, 3 weeks, and I pointed out the bits that were missing, were slowing me down, weren't working to my coworker, and he agreed that we should try migrating the Yesod. We did, and then the problem was solved. Now, I know you're probably not thinking it as a style thing, but if we talk about style, there's actually been 0 problems. So I have to talk about something else where there's been like a difference of choices or opinions, right? So that's one. Another would be my coworker wanted to use free monad for our email router. And I thought it was a bad idea and that it would be more work than it was worth. But you know, it was his task. So we discussed it and I said, no, let's try it, right? I wasn't gonna stop him. We tried it and all I had to do was wait for him to get tired of it and then he removed it, right? So, you know, if that's the main component he usually works on, it's not really my problem if he's got that thing running around over there, right? Differences of style. It mostly hasn't been a problem, but I'm a little bit fortunate because some of the contracts and gigs I've been brought in on, it was as kind of a fix-up artist to clean up what was already there. So I already had carte blanche to just, yeah. So I've had a somewhat easier time than that. I guess the only advice I would give you is to just try to use more popular stuff that's a little more hammered out, and you're less likely to have to replace it later. That's all I would say. But no real like code style conflicts.
How do you determine popularity?
Well, this is going to sound biased, but I tend to trust things from FP Complete. Now, we've never hired them or worked with them. I have no idea what that's like. They're available, like you can hire them as a consultancy, right? That's not actually why I use their libraries. Their APIs aren't even necessarily my favorite in terms of the actual design. I use them because if I PR a library that FP Complete or MicroSlimmin maintains, it ends up getting merged the next day, every time. They're super responsive. The other benefit of using it is because FP Complete gets hired onto a mix of jobs for different clients, they actually use the stuff that they make, and they get bugs hammered out for you. The problem with a lot of package is that that's not true for every library. Case in point, Bloodhound. I wrote it, I don't actually use Elasticsearch anymore. I just wrote it because I was angry at Elasticsearch's API. Accordingly, I let the 2 other main maintainers who actually use Elasticsearch at work dictate most of the actual API design. The only time recently where I put my foot down was on the version split for the modules. So, that's how I generally choose things, is I look at FP Complete. It's also, I'm subscribed to the Haskell subreddit, for example. That can help you get a sense of what people are talking about, what people recommend, what's getting regular releases, that sort of thing. I actually co-wrote a blog post with my coworker called Haskell Pitfalls. It's on lorepub.com. And one of the subjects is abandonware and identifying actively maintained libraries on Hackage. And we have a bit of text here about how to figure that out. So consider reading the post. That good?
Yeah. You said something about free and how it was more work than necessary.
Yeah.
Can you elaborate a little bit more on that?
It's a long, ongoing debate. So the question is about free and it being more hassle. So you basically always have this functorial structure between you and the next step of your thing. So you have to keep lifting over each next step, and it gets really tedious. If you want to know what I mean, just try it, seriously. You'll find out in 15 minutes what I'm talking about.
I mean, John's going to say the opposite.
I know. That's why I said it was an ongoing debate, because most of the debate's ongoing with him. Yeah. And I don't care. It sucks and it's boring. All right, yeah?
You mentioned build an open source portfolio. Are there any Haskell ecosystem specific tips you could provide for that, or is it kind of just the general how you would go about it?
Well, I mean, there's pluses and minuses to the Haskell ecosystem, right? The stuff, even stuff that isn't really super frequently maintained, often it's just because it's done, and you just don't really need to fiddle with it much anymore. So any further releases from that point are just version bumps. So you get some nice libraries to build on top of. From there, I mean, the flip side to that is there's more gaps in the ecosystem than say something like Node.js. You cannot, off the top of your head, pick a project that hasn't been done 10 times already in Node.js, right? Seriously, I dare you. Come up with something I can't find in NPM. Anybody? No? See, you know better. All right. So the gaps are opportunities. It's an opportunity for you to kind of stake your claim, try to present a solution to the problem. In terms of building a portfolio, I mean, so I have a friend who actually is going through this right now, trying to build a portfolio, get his dev career in Haskell going. He's worked as a Rails dev before, but after learning Haskell, he actually really doesn't want to anymore. So he's trying his best to get a job in Haskell as a junior dev, right? So the advice I've given him and what he's doing is a bit of both. He created a new project called Ballast that I have been very, very lightly helping him with. He's done all the work. And it's bindings to the Shipwire API, which is a fulfillment service. And he wrote all that. I just did a little bit of code review. So he's got a library in his name now. But probably what he's going to focus on next is contributing to other people's libraries so that they know he exists. Right? That kind of thing. In terms of how much a portfolio is going to help you, it's going to help you less with a career in Haskell than it would in, say, Node.js or Java, just because there's fewer employers to, really avail themselves of that knowledge, right? But it will help, especially if you're on the more junior side, and you need to do more to prove that you know how to do all this stuff.
there is one gigantic drawback to learning Haskell. You'll never be satisfied in another language.
Yes.
Yes, that's exactly what happened to my friend. He did Rails, he learned Haskell, and then he was dissatisfied with everything else. Young guy, only a few years worked as a dev, right? Already ruined for everything else.
As a, something to add to that is one of my team members, he's a Python and JavaScript guy, and he decided to try L, just out,
Right.
And now he says I can't go back to writing JavaScript.
Yeah. Yes?
One thing that I'd like to comment on about on all this craze that people are having, like, oh my god, I wanna do Haskell. Like I get that. I would also love to do to get paid to write Haskell. But I would also like to remind everyone that like the tools that you work, that's not everything, right? I mean, you can have a Haskell job, but your coworkers can be total asshats. And so, I mean, like, I get that people are crazy about wanting to use Haskell, but that's like really only,
right.
I mean, the programming language is a small part of your job.
Okay, let's move on from this.
Yeah.
All right, so I'm fortunate enough to have some really awesome coworkers that I really wish lived closer to me,
Awesome.
but I wouldn't give up being fully remote for that, as much as I like them. So I wouldn't say I have the best job in the world, but a lot of things are really good. Most of the bad parts are actually ops. I have to do ops at this company. It sucks. I hate doing ops. Did you have a question?
Yeah. So, my current job, I do code reviews a lot.
Yeah.
And code reviews tend to be ugly because I have to go through tests, and then after tests, I have to look at the side effects of writing. How does a code review generally go in working in a Haskell at work?
That's it. We just PR. Our CI is hooked into GitHub. It builds it. You see Ask Me's over here? Yeah, they just pick a reviewer. And they review the code. They either merge it themselves or they thumbs up it. If a build is breaking, we wait on review until the build's fixed. When the commit gets merged, the CI notices that there was a merge to, a change in master, and it automatically runs the deploy to production. So we have a full continuous deployment thing. And in terms of the actual pull requests themselves, I mean, that old joke about, the 5-line commit gets super detailed scrutiny, and the 5,000-line PR, it's like, nah, good.
Yeah.
There's a little bit of that. I think we're not as bad about that as a lot of teams I've worked on that have had code review, though. Partly because we're not so busy writing code that we can't take an hour or two out to review each other's work and ask questions. But it's a pretty lightweight process for us.
What build tool are you using?
Oh boy. We kind of hate it. So the question is, what build tool are we using? And the answer is our CI builds run inside of Docker, which is managed by Drone CI, which runs on a dedicated server. And then the actual deploy runs inside of an environment using Ansible. So, here's the problem with Drone CI. It is written by a gaggle of cowboy Go programmers who until recently couldn't reliably parse JSON for their own API. The caching doesn't work. They don't have build pipelines or stages, and we have to do all that with shell scripts inside of the build environment. We are probably moving to Jenkins next, except we can configure Drone CI entirely in terms of code, because you just have like a drone YAML, and then just your build thing, right? And Jenkins isn't like that. So yeah, right now it's Drone CI, but we'd like to get to something a little more powerful, a little more configurable, I guess is the way I would put it. You have a question? No? All right, sorry. Any other questions?
Last question.
Yeah.
How do you go about refactoring? Because people, every time we talk about the Haskell people, they like type something, refactoring, all that. But most of the people that tell me that are not working in Haskell. So.
Yeah, so the question was, how does refactoring go in Haskell? Most of the people tell me that refactoring Haskell is great, but most of them don't actually use Haskell at work. What you've heard is probably true, if I'm guessing what you've heard correctly. It is really nice. In general, when I want to refactor something, I either change a type signature on a function, or I change the definition of the data type, and I just let everything break. And I just start going down the list and fixing all the type errors. Now, one of the advantages of having Rosetta, which shares types between the backend and front end, is we change a type there to do a refactor. It breaks the backend and front end builds, so we just have 2 checklists instead of 1. And that's actually never failed to result in a successful build test run once the thing compiled. Will that always happen in Haskell? No. Their types don't capture everything, but for like quick refactors, yeah, it's nice. It makes making decisions less painful because you know you're not necessarily stuck with it for eternity, like I was when I wrote Python. That was fun. So, yeah.
One last question. So,
yeah.
Are there certain kind of problems or situations in which you would not use Haskell?
Situations in which I wouldn't use Haskell. Systems programming. Situations where I can't use a garbage collector. I wouldn't use Haskell for that. However, there are embedded toolkits for generating code that are essentially use Haskell as a DSL. Clash from earlier comes to mind, right? And those seem to make their users pretty happy, but I am not an embedded programmer, so don't ask me. Yeah, I mean, if I couldn't tolerate garbage collection and I knew I needed like absolutely 0 costs any more than necessary, I would probably end up using C++ or Rust, depending on like what kind of tools and libraries I needed. Yeah, but that's about it, because for me, Haskell kind of encompasses the gamut of Java to Ruby, with the expressiveness more on the Ruby side and performance more on the Java side, although certainly the garbage collector and GC could use a bit of love. But yeah, for the kind of work I do, there's no reason to use anything else really.
Numeric computations, things like that?
Well, okay, numerics. There are some people doing numerics work in Haskell. Most of them are in finance. Stephen Deal comes to mind. They, again, seem happy with it, but because I don't do numerics, I don't know the limitations of those libraries for doing numerics work in Haskell. Is it the most popular thing to do numerics in ever? No. I mean, if you're doing machine learning, you're just going to use Python, right? Like, that's just how it is. But for just like general business applications that don't have like these very specific ecosystems of libraries that you need to use, then yeah, just use Haskell. Any other questions? Okay, so we've got just under 15 minutes left. I decided to give you guys a break from going through another library, since we wouldn't have enough time for it anyway. Instead, I'm just going to show you something kind of cool. So, real quick, who can raise their hand and say they learned something really cool in 2016? All right, cool. What'd you learn? Just say what it is.
2016?
Yeah.
I learned about refinement types in liquid Haskell.
Okay. Morgan?
Oh no, you're putting me on the spot here.
You didn't ask any questions, so.
Something cool I learned? I learned about traits in Rust.
Cool. All right. All right.
Phantom types.
Phantom types. Those are a fun one.
The difference between dependent types and dynamic types.
Oh, yeah, there you go. All right, so one cool thing I learned in 2016 was instance local functional dependencies. And I only learned that they existed. I didn't know it was even possible because I was trying to write fancier looking code than a Rubyist. So, who here has written Ruby before? It's fine, it's fine. You just need to be familiar with like what it looks like. So you know how Ruby will like overload their literals and classes with like extra helper methods? So you can have like one dot here and things like that. So I wanted that in Haskell, just for giggles, right? Now obviously in Haskell you can write year 1, where year is a function, and that works fine. But that's not English. That's not English. because code isn't good unless it looks like English, right? We totally want to embed our semantics in a completely ambiguous human language. That's what we want it to look like. All right, so okay, so obviously this isn't a proper time library because I'm just normalizing everything into seconds. But the problem I had was that I could write, let me move it to the top here for you. I could write that, and I was close, right? But the problem was I didn't have good inference. Because if I don't supply the type, well, okay, for starters, I need to actually activate them. Yeah, there, we get an ambiguous type error because it doesn't know which type class we're talking about. You don't, so here's a trick for GC type errors. Just like remember the first like 3 or 4 words, and then just kind of hand wave at the rest. All right, so my problem is that essentially what I want to do, everybody here is familiar with the num type class, right? And the fact that a num, a numeric literal, wow, this bottom of terminal thing is a real mess. Okay. Do something like that. Okay, so if you have a numeric literal, it's just num t and then it'll convert into whatever concrete type it eventually becomes. Our problem here is that what we're trying to do is make an instance of num, which is partial, by the way, because we're only implementing from integer, right? You can't actually add and subtract these bad boys. Although I probably could implement that. And I'm trying to make a function work as a numeric literal. A function is a number. Yeah. Okay. So what it actually is, though, it's really just like a glorified flip and multiply operation. So the first thought I had is, you know, if I had something like functional dependencies, which are designed to help with inference, and what functional dependencies do, you see them in MTL a fair bit.
So, sorry, can you explain
Yes?
why are you getting the ambiguous instances?
Because it doesn't know what instance I'm talking about. Like, it can't go from a numeric literal to that function type because it doesn't. It's the return type that's the problem. Because even if it knows the argument, it can't actually completely concrete the possible type class context. Because I'll show you in a moment after I point out the functional dependencies here. So the idea of finding functional dependency is to say that one type argument will uniquely determine the other. And that's actually what we want, because what it's struggling with here is the fact that when we have 1 years, well, it knows it's starting with time convert because years is just this data constructor and time convert, right? So it knows that, but it's not willing to make the leap of logic to complete the rest of the context. Because the context isn't just this part, it's also this part, right? So it doesn't know the return type. When I assign the type like this, I'm giving it the return, yes?
But if you put that in a context that needs a diff type, will it figure it out? Or?
Yeah, if you use the result as a diff time, it can thread that up, yeah. That's actually one of the things Haskell's really good at, is not losing track of information that can feed the type to other places. It's actually much better at that than Scala and some other languages. So, all right, fair enough. So, what do we want here? Well, what we want is a functional dependency where we can just say, if it's this, then go ahead and assume this, the return type is diff time, right? We want kind of like a latch. So it turns out, and I still incredibly tickled by this, if you turn on type families, you get a type equality operator. And the type equality operator can look like that. And the type equality works like a constraint, right? It's just like a type class constraint, but the constraint is on the equality of a type variable. Now, you're probably wondering, why is that useful? Why can't I just say A is int? Well, we already said A was diff time, and it didn't work for the solver. So what we do is take advantage of the fact that the constraint solver works in stages. It's not an all-in-one-go thing. So we make this A, and this A, but it's not actually any A in the universe, right? We know A is actually diff time. So what we do is we shove A out to a constraint on the instance so that in the first step, it'll find this instance, see that any return type is fine, right? Any return type is fine. Pick the instance, so now it's resolved, and then when it goes to actually make use of the dictionary, it just knows it's diff time. So then what happens when we reload this is we don't need the type signature anymore. We could actually, I have aliases, so you can do like 1 year, 2 years, so on and so forth. So we now have numbers that are functions through instance local functional dependencies. And I was incredibly tickled to find out about this.
Are you going to use it?
Huh?
Are you going to use it?
No, no. This is just to scare the other Hasslers into thinking I'm going to spread Ruby code everywhere. It's just terrorism, that's all. I don't actually use this or anything.
And now I guess you can also compose them now. You can say 1.2 and 3.
I don't know. Nope. Because it expects time convert as an argument, right? And that's going to bottom out because we didn't implement summation. Although I think we could actually. I don't think there's anything stopping us actually implementing sums of the numbers. But yeah. Yep.
Did you try the dependencies way of doing it, and what happened?
So the problem is we don't need like a class level functional dependency because we don't have, num has one type argument, not two. We need the ability to talk about two different types kind of in a specific instance, not a general property of the class. That's why it's instance local functional dependencies instead of just the normal ones that are on the class. Because the reason MTL needs them is because they have multi-param type classes, they have two arguments. Num isn't like that. So you can only talk about the final type, but the final type in num is the entire function type. We can't talk about the subcomponents. Yeah. Yes?
I see how you needed to add the type families extension in the end to do this, like, yeah, I got that. What exactly do flexible context and flexible instances, what exactly do those two?
So you need that because I'm making, so flexible instances and flexible contexts are because the strict Haskell 98 rules for type class contexts require that they be maximally general. There's actually like a list of rules in the Haskell report. I don't have them memorized. Basically, GHC says, hey, you can't say this unless you have flexible context. And then I look at the type and I go, oh, right, because it's a little bit, you know, hinky or weird or something, or it's got like a concrete type or a function type or something in there. And then, you know, I'm like, all right, fine, I'll turn it on.
Okay.
It's just one of those extensions where if GHC asks for it, you just flip it on.
Yeah, sure.
It is sometimes an indication that you're writing a type class you shouldn't, though. Sometimes. Like, you shouldn't actually write this.
Yeah, sure.
It's bad.
that I get.
It's very bad. Do as I say, not as I terrorize. All right. Any other questions? No? All right. We're out of time. Thank you.